Hi guys, let's solve the question longest substring without repeating characters. So we've been given a string and we have to find a substring without any repetitions, and we've got to find the maximum substring, the maximum length of the substring that can be obtained in this manner. So substring is a contiguous set of characters. Here we see we can have a substring of 1 without repetition, substring of 2 characters, 3 characters without repetition. This is not valid because there's a repetition here. So there are a couple of ideas that come to mind. One is we can do a double for loop, and we can say, let's start here for the outer loop and let's go check every character here for the inner loop. So we'll start with this, and that would be a length of 2. Then we'll move the inner loop here, and that would be a length of 3. Then we'll move the inner loop here, that would be a length of 4. Well, that would not be valid, but either we put a break function in there when it's not valid, and it breaks out and goes back to the outer loop or not. This is going to be an O of n squared solution because we will continue to, in theory, have a possibility of n minus 1 lookups here in the inner loop, and we have to have the outer loop move n times 2. So that's an n squared solution because O of n does not refer to an average time or the best time, it refers to the worst time, worst possibility, and it is quite possible that this character here was situated at the very end, or so in which case the inner loop's going until n minus 1 times. The second solution is we can have a sliding window of sorts, meaning we start the left and the right here, and then we move the right pointer here. So we say, is the character on the right pointer, is it already in the string? Well, it is not. So we move the right pointer further because we have to find the maximum substring, the substring with the maximum length. So we move on until here, and we see C is in the string right now. No, it's not. So that's good. So we've got a substring of length 3. So we move the right pointer further, and we encounter A. So we see, is A in the string or not? It is. So now this is not valid because it's a repetition, and we have to find a substring without a repetition. So what do we do? Well, the first question is, how do we look up? Because if we are looking up the string again and again, we have to find a way to make the lookup fast. And how can we make a fast? Well, if it's a constant time lookup we can find a set. We can use a set. We don't need to use a hash map because there's no corresponding value that we need to find. We just need to find whether this particular character exists or not. So we'll use a set. So basically we'll keep our string that we've looked up until now in a set that would make the lookup easy. But once we find that it is in fact there, this rightmost character is in fact in the string, what we'll do is we'll start removing items from the left side until it becomes unique again, meaning until this character is no longer found in the substring. So we'll remove this A. Now we'll be left with BCA. So we are still looking in the set and we don't find A anymore. So that's a good sign. That means that it is a unique substring. There are no repeated characters. Again, we'll compute the length, and the length is 3. All right, that's good. We'll keep moving the R pointer, the right pointer. We'll see B. So again, we'll look up in the string. Now A has already been removed from the set because it was repetitive. So we already had removed it, but this is the current string. We see, is B in the set? Again, it is in the set. So we'll have to clean from the left side until this is no more the case. So we'll remove B. And as soon as we remove B, we find this is a unique a substring with unique characters. So this is good. So we compute the length again. This is length 3, which we already had in the past. But again, the longest substring is of length 3. We move the right pointer here. C, again, we check in this, check the set that has got these 3 characters. Again, we remove from the left. And once we remove the leftmost character, we are left with A, B, and C. So this is a unique combination again. So again, length 3. And we'll do it so on and so forth. But this is the interesting one. So let's just do this one as well. So we are at A, B, C, and then we add B. So again, we'll look in the substring and we'll see, is B available in the substring? Well, it is. So we start removing from the left. So we remove A, but B is still there. Just because we removed the leftmost element did not make it unique. So we'll have to remove B as well. So we'll be left with a substring of length 2, C and B. So this is shorter than what we had before, which was length 3. So we'll still continue to move on. And then this last one is B. So again, we'll have to remove C and B. So it would be just a length of 1. So I said, I think we've discussed it quite enough. Let's code it up. We need a character set. So let's that have that set up. And then we need a left pointer, we need a right pointer, and we need the, so let me just do the left and right pointers. Now, why are we setting right at the same spot as left? It's a little convenient in terms of code, because if I had set right to be one next to the left, I do intend to add the right character in the set. So if right was never here, I would have missed adding this particular character to the set. So it's more of a convenience. I mean, one can actually, for the first iteration, just add this in the set to begin with and then start right at one. But here we can just accomplish the same thing by starting both of them at index 0. So we've done that. We have to have a global variable that computes the maximum length of the substring. So let's define it as result and set it to 0. So now what will we say? We'll say while r, which is the right pointer, because that's what we have to continue to move forward, while this is less than the length of s. So while this is less, and then so this is the outer loop. We are moving further. Now, just because there's an outer loop and inner loop does not mean this is an O of n square solution. It is an O of n solution. Why is that? Because the outer loop will continue to make R move forward, and the inner loop, which is not a loop, but it would actually basically have the left pointer move further. So R will continue to move forward, and L will also join it in some instances, and it would not in the other instances. But the number of iterations overall will be n, equal to length of the string. So now what are we saying? We are saying if we, we so we'll say if S of R, meaning if S of R was in the character set, if S of R was in the character set, then what do we have to do? We'll have to remove the leftmost portion. So we use the function remove for sets like this. So we'll have to remove the leftmost character, and then we'll have to check again whether, once we remove the leftmost character, whether S of R is still in the character set or not. So that's why we cannot do an if, because if we were doing an if, that this would be a one-time occurrence. But we saw here in an example, for this string, we saw that B was not the leftmost, it was second to the leftmost. So we cannot use an if, rather we'll use a while here. So while S of R is in character set, we have to continue checking and removing the leftmost character. So now that we have removed, and every time we remove the leftmost character, we have to increment the pointer by 1, so as to, otherwise it would remain stuck on that one. So we have to increase the leftmost pointer. Okay, so now we are left with a situation where there's no repetition. So if there's no repetition, then what do? We add that rightmost character to the substring. So this is what we do. And after we have added, because now this is a legit substring, uh, because we'll have to compute the maximum length, and we could not compute the maximum length before adding it, otherwise we'll be short by 1. So now we know this is a legit string, and now what will we do? We'll compute the length. The length is r minus L plus 1. So either we can have a variable and call it a local length or something, but there's a quick design pattern for this, which is you can just update the global variable right here. You can say result, which is the global variable, is the maximum of what it already was, comma, what has been computed, which you can call the local length here. But if this local length is greater than what was already there, then the result would be updated. So we can do it in this fashion, and then we can say return result. And here it should be character set, and this looks fine. Let's give it a run. Okay, what happened here? It says character set dot remove s of l, here be length of substring. If s of r is in, so it this is an error here, and it seems like it, well, what happened is, because we started with, let's say, a, and initially it was s of r was not in the character set. So so there was nothing to remove. So this was not even looked at, but it added s of r, and then it calculated this, and then it went on looking here again, and a was in fact there. Now the problem is that we should have set r plus equals to 1, so we forgot to increment the r pointer in the while loop. So now that we've done that, it would actually go on to the b instead of looking again at a. So let's do that. All right, so this is the thing that we have to be cognizant about, meaning while we are using the while loops, we do have to increment it, otherwise it's not going to keep working fine. All right, that should be it. Thanks.